Okay, good morning, students. We're here doing properties of similar triangles. All right, and we're going to be talking about AA and SAS. So similar triangles have congruent angles. All right, and they have proportional sides. All right, that's a fact about all triangles, and we're going to use this fact and really go to outer space with it and talk about some crazy stuff. All right, and realize the notation for similarity is a squiggly line. That's the notation. All right. If angles in one triangle are congruent to the angles in another triangle, then the corresponding sides of those triangles are proportional. That's a fact. So basically it's saying that if two triangles have the same angles, their sides have to be proportional. That is for triangles. This is not true for quadrilaterals. What's a quadrilateral? It's a shape with four sides. Why is this not true? Okay, we got this shape right here, known as a square. All the angles are right angles and all the sides are going to be same. We'll say they're all 5. Now, watch this. This shape over here is a rectangle. All the angles are still the same. That side length's 5, but now this is 15. All right? So the corresponding sides don't have the same scale factor. All right? It's only true for triangles. It's not true for quadrilaterals. So, problem number 1, does this picture on the right give enough information to prove that triangle ABC is similar to triangle DEF? And the answer is actually yes. Why? All angles are congruent. All right, some of them are very obvious. What do I mean by that? Well, A is clearly congruent to D. C is clearly congruent to F. B, on the other hand, we actually know that they are, similar or congruent. We know that they're congruent. How? Let's just make up some stuff. Well, this is, let's call that 40. So D's 40. If C is then 80. So F is 80. Well, notice that since triangles add up to 180 degrees, triangles add to 180, that B and E would both have to be 60 degrees. And this is actually the third angles theorem. I don't know if we're going to talk about this later. Maybe we will, maybe we won't. But if you know two angles are the same, the third angles have to be congruent. So basically, we're talking about bare minimum information we need. Remember back to Unit 4, we had side, angle, so on and so forth. We're going to have similar stuff here, pun intended, get it? Because we're talking about similarity. If two triangles have two pairs of congruent angles, and then triangles are similar. So that's basically the bare minimum information you need to know. Two angles are congruent. Two pairs of angles are congruent. So we have that. So now we're just going to practice doing some things, talk about similarity, so on and so forth. All right. So in the diagram below, triangle ABC is similar to triangle DEF. All right. So C, we got to basically find half the alphabet. We got to find V, W, X, Y, and Z. Angle C is 100 degrees. That's the last one. Angle F is also going to be 100 degrees. So we automatically know Z equals 100 degrees. That required no calculation. All right. Next up, A is the first letter. D is the first letter. We know that those are corresponding. So Y must also be 30 degrees. All right. Now, we can use the triangle sum theorem, say, well, x now has to be 50 degrees because the whole triangle adds up to 180. So just using some facts about congruent angles and all that fun stuff, we can immediately find x, y, and z. All right? Angles are congruent. Sides, on the other hand, are proportional. All right? And this is going to be a huge punchline moving forward. All right? Let's do W first. All right? We're going to find W. Now, it's just really about matching up corresponding sides. 12 corresponds to 16. Since we start on the triangle on the left, I'm going to start on the triangle on the left again. 9 corresponds to W. All right, this is a true proportion I'm allowed to set up. And if you can set this up, if you can get this far, you're in very good shape. Because then from here, just cross multiply. 12W equals 144. Divide both sides by 12. And W equals 12. Boom. All right, and then we got to solve for the last letter. We got to solve for V. And again, there's a bunch of ways you can set these proportions. I'm going to set this one up slightly different. I'm going to just do 12 over V. The top side on the left, on the right side on the left. All right, 12 over V. Well, then that's going to equal 16 over 8. Okay, and then we can just cross multiply. I'm going to get 16V over 96. And then divide both sides by 16. And V equals 6. Boom. Alright, so it's really just angles, congruent, sides, proportional, doing all that junk, so on and so forth. Alright. Just cruising right along. I can prove two triangles are similar using AA postulate. So these two triangles are similar. Actually, this was supposed to be written down here. We got to find measure of angle F. Well, realize F is the last letter in the similarity statement, C is the last letter, F, C, so that's going to be 86 degrees. Now to find B, I'm actually going to find E, because I'm just going to use the third angles theorem. Alright, angle E plus 86 plus 62 equals 180 degrees. Alright, just doing some work on my calculator now. Measure of angle E equals 32 degrees. And then since it corresponds to B, I know that's also 32 degrees. Alright, angle A corresponds to D, so that's 62 degrees. And then this last one, we have to find the length of FE. So again, I had 18 and 30 on this left-hand triangle, so I'm just going to do 18 over 30. Well, what corresponds to 18 on the other triangle? Well, that's 12. And then FE corresponds to 30, so that has to be in the denominator. If you can set up this ratio, this proportion in orange, incredibly good shape. Just cross multiply. And then we're going to see that it equals 20. Yippee. Alright. We'll continue the rest of the notes in the next video.